All right, everyone, here is objective 7. So this is unit 8, objective 7. I know it says unit 10, but it's not. It's unit 8, objective 7, the sine graph. So we're going to learn how to graph the sine function, okay? Accurately graph the y equals sine of x. You may see f of x equals sine of x. It means the same exact thing, okay? So we're going to learn how to graph the sine function. We will be graphing, but first let's explore a little bit. We're going to fill out this table right here, this values. We're going to fill it out in two ways. One with fractions, okay, it says fractional, and one with decimals, because sometimes we don't see the real value of something unless we see it with decimals, okay? So I know some of you, I'm going to try to teach it for different ways of perceiving or learning the trig ratios. So I know some of you use the triangle, the right triangles. Okay, oops, doesn't look like a triangle, but that's my best right here. Okay, so we use the 30, 60, 90. We do know their values. We have derived this over and over in previous lessons. We do know that across from 30 is 1/2. Adjacent to 30 is √3/2. And the hypotenuse or the radius is 1. Okay, so we're using the unit circle. We're using the radius, not necessarily the unit circle, but we're using the radius of 1 here to derive the values of the 30, 60, 90. So let's go ahead and use this, and you can also do your 45. You should have a little paper with it drawn or your notes. Okay, the 45, 45, 90. Across from the 45 is 1/√2 or √2/2, which is the most common one we see. Doesn't matter, one or the other is fine. And since it's A and A, so it's the same exact value, √2/2. And the hypotenuse is 1. So you can either use this to find the sine, cosine, tangent, or you can use the unit circle. It doesn't matter. You should have one or the other, or some other way that you prefer. Calculator is not going to be helpful unless I am talking about decimals. That's the only part that the calculator is going to come in handy. We need the fractional part first. So we're talking about the sine of an angle. So I'm interested in the sine of 30 degrees. Okay. I'm interested in the sine of 30 degrees, the sine of 60 degrees, the sine of 45 degrees. We are, sorry there. After all, we are graphing the sine function, okay? So you can have your little list or your unit circle. I'm gonna go through this a little bit fast, okay? So the sine of 0 degrees, it is 0, okay? 0 degrees, the sine of 0 degrees is 0. The sine of pi over 6, which is equivalent to your 30 degrees, the sine there is 1/2. Okay, the sine of pi over 4, which is equivalent to your 45 degrees, it is √2/2. And the sine of pi over 3 is √3/2. So if you notice, pi over 6, pi over 4, and pi over 3, I'm going to highlight, I'm going to put this right here, I'm going to box them. This is our quadrant 1, okay? This is our quadrant 1. Okay, the sine of 1/2 a pi, it is 1. The sine of 2/3 of a pi is √3/2. The sine of 3/4 of a pi is √2/2. And the sine of 5 pi over 6 is 1/2. And the sine of pi, it is 0. Okay. Okay, now notice that 2/3 of a pi, 3/4 of a pi, and 5/6 of a pi, it is in quadrant 2. Now, we have practiced graphing. Some of you are very familiar with the unit circle. Some of you are very familiar with graphing, so sketching angles. So we know that these are in quadrant 2. So I just want to point that out. The first 3 over here, oops, was in quadrant 1, and the other 3 was in quadrant 2. Okay. Let's continue with our fractionals over here, okay? So the sine of pi is 0. The sine of 7 pi over 6 is negative 1/2. The sine of 5 pi over 4 is negative 2 root 2. The sine of 4 pi over 3 is negative root 3 over 2. And the sine of 3/2 of pi is negative 1. How do I know this so fast? Because I have them memorized, or I look at my unit circle, or I look at my little table that I created, okay? Little table that I created, I can look at them faster, okay? The sine of 5 pi over 3 is negative root 3 over 2. The sine of 7 pi over 4 is negative root 2 over 2. And the sine of 11 pi over 6 is negative 1/2. And the sine of 2 pi is 0. Okay, that's how I know them so fast, is either I look at the unit circle, I personally know them memorized, and or you can look at a table. So notice that 7 pi over 6 is 1 over, is always, the numerator is 1 bigger than the denominator. This puts us in quadrant 3. Sorry, for some reason I cannot do a straight line here. This puts us in quadrant 3. And then 5 pi over 3, 7 pi over 4, and 11 pi over 6 puts us in quadrant 4. So we have 4 quadrants covered here. Okay, we went all the way around the circle. Okay, now let's use the calculator and switch these fractions to decimals. Well, 0 is 0. 1/2 is the same as 0.5. Root 2 divided by 2, if you do it in your calculator, you get 0.7. Square root of 3 divided by 2, you get 0.9. Well, 1 is just a 1. 1 over 1 is 1. Root 3 over 2, we just did it right here, is 0.9. Square root of 2 over 2 is 0.7. And 1/2 is just 0.5. So these numbers are repeating, and 0, 0. Okay, they're repeating. As a matter of fact, it goes from 0 and then increases very slow, 0.5, 0.7, 0.9, and increase all the way up to a 1. It's kind of like you're going up a hill, like start at 0 and you go up, 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 and then you hit a 1, okay? And then it comes down like, 0.9, 0.7, 0.5, and boom, 0 again. So it looks like we went up a hill and down a hill, okay, with those numbers. In quadrant 1, I went up, and then in quadrant 2, I decreased. Okay, so I increased and then I decreased. That's what it looked like for me here, if you look at the numbers, like a little pyramid or a mountain, okay, little mount. Okay, let's do the same exact values, but now it's negative. 0 divided by 0 is 0. A negative 1/2 is negative 0.5. This would be negative 0.7. This would be negative 0.9. So it's the same numbers, but it's negative. Interesting. In quadrant 3. And then negative 1 divided by 1 is just negative 1. This negative square root 3 over 2 would be negative 0.9. Then negative 0.7. Then negative 0.5, and then a 0. So it looks like we start at 0. So let me do a little drawing here on the side. We start at 0, and then we start slowly declining, decreasing until we got to a negative 1. And then we kind of like came back slowly all the way back to a 0. So in quadrant 1, I increased, hit a 1, decreased, hit a 0. In quadrant 3, I decreased slowly, decreased all the way up to a negative 1. So that was quadrant 3. And then slowly I increased back up to a 0. That was quadrant 4. So how can we put this idea together, these two pieces together, if we combine them? It does not put together to make a circle, okay? But let's see with these values, what does it look like? Okay, I'll do it again up here in a much nice organized way. So if my X values are my angles, my X axes are my angles, and my Y values are just regular values, 1/2, 1, 2, because that's the values I keep getting over here with my decimals, okay? That's the Y values. So if I create an order pair, the first order pair I see here, let me highlight it, is 0 for X equals 0. So my angle was 0, my Y value was 0. My angle was 5 pi over 6, my value was 1/2. So those are order pair that I'm creating here. So I got a 0, 0. Let's go to some easier ones to look at. 1/2 pi right here, Okay, so think about this coordinate right here, half a pi comma 1. Half a pi up to a 1. Let's go to pi comma 0, another order pair right here. Pi comma 0. Let's go to another one. Let's go to 3/2 a pi comma -1. So 3/2 comma -1. And then let's go back to 2 pi comma 0. Right here is another major order pair that was easy to look at, right? So remember I said over here in quadrant 1, we were increasing. Remember right here at pi over 6, we had a half. So it looks like I was right here. Okay, but I also was at a half at 5 pi over 6 right here. And then I was a negative a half at 7 pi over 6. So 7 pi over 6 negative a half. And I was also at negative a half at 11 pi over 6 right here. And if I put the 0.7s, the 0.7s and the 0.9s, okay, somewhere here and so forth. Look at how nice. That was our first quadrant. Oops, I missed it. That was our first quadrant. Missed it. Holy moly, I missed it by a lot. I'm not good at drawing this pad right here. So that's my first quadrant, okay, this curve. And then my second quadrant, I came down, the numbers decreased. And then I went down, and then I came back up. So those are my quadrants. If I try to go retrace it, it's going to be messy. It's supposed to be a nice, smooth curve. Well, obviously mine does not look smooth at all, right? So notice, I'm going to switch my color. I just want to show you something. In quadrant 1, my values of y were all positive, okay? And then in quadrant 2, my y values are still positive. They're just decreasing. Then at pi comma 0, we hit it right here. And then notice in quadrant 3, my y values were negative. Okay, it makes sense because in the quadrant 3 right here, the y values are negative, and so are here in quadrant 4. So in quadrant 4, my y values are negative. So over here, the y value is positive, and over here is also positive. It's the sine function, right? The sine of theta, the sine is positive, and then the sine is negative here, and then the sine is negative here. So I want you to see the pattern, the beauty of this graph right here. It matches perfectly. So that is the basic graph of our sine function. Let's answer a few questions based off of our graph. Okay, it says, note if you continue substituting in values, you would see the pattern repeat as you go to the left of x equals 0, into the negative, and to the right of 2 pi. That means like if I keep going around the circle over and over again, right? I went around, sorry. So I went around first quadrant, second quadrant, third quadrant, fourth quadrant. If I keep going around and around and around, the pattern is the same. So I can even put in blue. Let's put it in blue. Okay, I can say, hey, the pattern is going to be the same. I'm going to come down eventually and come back up. And the pattern is going to continue forever, going up and down forever, because it's the same values over and over and over. Okay. So that means that the function, when they repeat over and over and over, this means that the graph is periodic. Okay, periodic means the values are going to repeat over and over and over. It's not going to change. Okay, it's going to follow the same exact pattern because we're going to go over the same exact angles with just coterminal angles. Okay, so what is the highest value? I'm not asking for the coordinate. I'm just asking you for the highest value. The y coordinate shows me my highest value. Well, the highest we hit was right here at 1. Okay, we went as high as 1. At where? At what location of x value did that happen? Right here, half a pi, that's what matched with the 1. Okay, so at half a pi, it matched with the 1. It makes sense, right? Half a pi, comma 1. And then what is the lowest value? Well, the lowest value we hit right here was -1. And where did that happen? It happened at 3/2 of pi. Okay, so 3 pi over 2, 3/2 was our lowest value. Since this function goes on forever and ever and ever to the left, negative infinity, and it goes on forever and ever and ever to positive infinity, we can safely say that our domain is from negative infinity to positive infinity. However, our range keeps bouncing up to 1, down to -1, up to a 1. Okay, if I continue with my graph, I'm going to go up to a 1, back to 0, down to a -1. So my range, we're going to use brackets to say that is included, okay, is included between -1 to 1. Okay, it's a closed range. It's included from -1 to 1. We always go from low to the highest value, okay, from low to high. So there's our range, there's our domain, the highest value, lowest value. Our function is periodic, it goes on forever. Now, I would like for you to just focus on one period of the function, meaning we start here and we go quadrant 1, quadrant 2, quadrant 3, quadrant 4. Done. If I repeat again, I would be on quadrant 1 again, quadrant 2 again. That would be a second period, meaning a second rotation around. And I don't want to do that. I just want one rotation around. Okay, one period is good. All right. So, and that's the basic sketch of the sine function. Let's talk about a word that we're going to use a lot, which is called the amplitude. Okay, the amplitude of the curve, it is, since it goes up 1 and down 1 from the equilibrium line, okay, where the elevation is 0. Okay, the equilibrium line is where we hit the 0. The amplitude is always a non-negative value. So what is the amplitude? The amplitude, in other words, to make it easy for me to remember, is just the length. Okay, it's the length of the curve. So let's go back up so we can understand amplitude. So it's not the length going left and right, because we go on forever to the left, we go on forever to the right. It is the length, the vertical length of my curve. So I go up 1, so let me highlight that, okay? I went up 1 and I went down 1, and then I would go up 1 and I would go up 1 and down 1. That would be my amplitude, okay? It's like a wavelength, okay? The wavelength always go up 1, down 1, up 1. So our length, our amplitude is of 1, okay? Now, why is it always positive, Ms. Myers, even though it went down? Because the length of, let me get blue. The length from the line of equilibrium to the lowest point is the length of 1, okay? From the 0, the line of equilibrium, to up to the highest value, the length is 1. And it'll keep going 1 and 1 forever, okay? So the length from the line of equilibrium. Why is it called the line of equilibrium? That's where the elevation is 0, right here, 0 and 0 again. So that's where we call it the line of equilibrium, okay? All right, so hopefully that made a little bit of sense. Let's practice some more so we can understand. So now we talked about period, we talked about amplitude. Here we go, we're talking about period again, which is another word we use all the time when we're graphing a sine function. The period is always 2 pi. One period is 2 pi, okay? Since it repeats its pattern every 2 pi, so 2 pi is 1 period. After that, it can go on, but it keeps repeating the same values, okay? So this is the general shape. We call it the parent graph of the function. The A is our amplitude, okay? This big letter A over here is our amplitude. This is the translated function, just like we translated parabolas, we translated absolute values, we translated linears, we can translate a sine as well. The H represents our left or right shift, okay? We call it our horizontal shift. And our K value represents our vertical shift. We go up or down on the, it does not make the length longer. The curve is determined, the length of the curve is determined by the amplitude, okay? The H and K, the starting point H comma K, it will determine my line of equilibrium, okay? If I shifted the function up or down, left or right, Okay, so think about line of equilibrium will be shifted if I shift my function up or down. So here's my line of equilibrium. All right, so let's go ahead and do one that is shifted. All right, here we go. So focus on the 5 key points. I want a beginning, there's one, a middle, an and, a quarter, and 3/4. So we want 5 points to sketch the first period only, okay? So let's see what we got here. We got f of x or y equals 2. There's my amplitude. Let me put a big A. Okay, so my amplitude, I'm just going to put amp. My amplitude is a 2. Sine of x, and then I have this -1 floating outside. So I don't have a horizontal shift. If I had a horizontal shift, guess what? If I had a horizontal shift, I would put it inside of a parenthesis. Okay, I don't have a horizontal shift, so this is my vertical shift. Okay, oops, I'm sorry. It will take me a while to get used to this program. So here we go. Back to our starting point, h, comma, k. I don't have a horizontal shift, so I'm going to put 0, but I do have a vertical shift. I'm bringing my function down by 1, okay, shifting it down by 1. So I think I have everything I need to start. I know the general shape of my function. Because my amplitude is positive, I'm going to start going up, and then I'm going to hit a maximum. I'm going to come down. I'm going to hit the line of equilibrium, and then I'm going to go down for my curve. And that's what my graph is supposed to look like, okay? Because the amplitude is positive, we're going to go, it tells me the direction as well. It not only tells me the length, it also tells me the direction. Okay, so let's go ahead and start at 0, -1 is right here. I'm going to draw a line of equilibrium. Okay, nice little dotted line of equilibrium. Let's put a little arrow and a little arrow. Okay, notice that these dashed marks are marking my half pi increments. I have a half over here. Let me go ahead and put a half. Then I have a whole pi. Then I would have 3 halves, and then 2 pi, and then I would have 5 halves. So the in-between are the half a pi's, okay? So from here, that's my very first point. That's the beginning. Let me check mark that again. There's my beginning and my h and k. That's where we started. Then I'm going to move over to half a pi, and I'm going to use the length, which is my amplitude of 2. So I'm going to go up 1, 2, which puts me right here. I did not go to the number 2. I went the height of 2 from where I was at. Remember, we are at -1. So I went up 2, which put me at 1. Then I come back to the line of equilibrium because that's the shape. Remember, that was quadrant 1, quadrant 2. Okay. Then at 3 halves, I'm going to go down the amplitude of 2. And then I'm at 2 pi, I'll come back to the line of equilibrium. Remember, this was quadrant 3 and this was quadrant 4. So there is our graph. Okay. So we have 1, 2, 3, 4, 5 key points. Okay. All right. What is the highest y value we reached? Well, we reached a 1. That was the highest value we reached right here. At what location did that occur? That occurred at half a pi. What is the lowest value? Well, I went as low as -3. So -3 it is. At what location did we get -3? At 3 halves a pi. 3 pi over 2 was the lowest, okay? Use a different color to extend the pattern in both directions to contain the x value of -pi. So they want me to go all the way to -pi and go all the way to 3 pi. So they want me to extend it all the way to this -pi and 3 pi. So let's use blue. If I continue the same pattern, I'm supposed to go down to -3 and then back to 0. Okay, that's my pattern right there. So if I continue the pattern, I move over and I go up 2, which takes me to a 1, and then come back to a 0. So that would be, and if you ask me to go any further, I would just put dot, 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 dot. It goes further. Okay, so there we go. We really care. The questions we were answering was only based on one period of the function. Started at 0 and he ended at 2 pi. Okay, so 2 pi was the period of my function, and I answer those questions based on one period of the function. Okay, let's do one more. Example number 2. Here we go. Let me switch back to red. All right, so now I have a -3. So my amplitude, oops, not n, amplitude, is always positive. Okay, amplitude means the length of my curve. So I know my amplitude is actually the absolute value of -3, which is 3. That's the length of my curve. Let me write it down. Length of the curve, or height of the curve, right? I'm gonna go as high as 3, as low as 3, as high as 3, as low as 3. However, this also tells me the direction. It tells me the direction of the curve. It looks like I'm going to start at my starting point and I'm going to go down and then back to the line of equilibrium, and then as high as 3 and then back to my line of equilibrium. So that's what my graph is going to look like. You got to analyze things before you start jumping into the graph. Okay, so I know the direction is negative. I know that some of you don't see this, but I can see this right here. Y equals -1 times 3 times the sine of x plus pi over 2. Okay, so this would tell my direction, and this would tell my amplitude. So perhaps you can see it that way. Okay, and this is still equals to -3. So it tells me my direction, it tells me my amplitude right there. All right, what is our starting point? Do we have a shift? Are we translating this function somewhere? We sure are. Whenever we want to translate left and right, we'll put it inside of a parenthesis for you. There it is. Okay, so I'm going to the left, pi over 2, and there is no vertical shift, so 0. I'm not moving my function up nor down, but I am moving to the left. But Ms. Myers says that's positive. But come on, guys, by now we know that is what value would I put in for x here to get a zeroed out back to my parent function? It would be the opposite of pi over 2. Okay, all right, so we have our starting point. Let's go ahead and put that in there. Let's label it, because remember that we only have the whole numbers here, the pi, the 2 pi, the 3 pi. Let's put the halves. That would be -1/2 here. That would be +1/2 here. Don't you dare ignore the 0. 0 pi is right there. 3/2 of pi is right here. So there we go. We got all the halves because they are important too. Okie dokie. Let's go ahead and start. Right here is my first point. We want 5 points. Let me draw my line of equilibrium in blue. My line of equilibrium is the x-axis. So I'm not moving the function up nor down. So you don't even see my blue line right there. Okay. All right. So we move over to the 0. We're going by halves. And I'm supposed to drop my direction down to 3. So 1, 2, 3, drop it down here. Back to half. Always go back to the line of equilibrium. So my first quadrant, my second quadrant. Move over to pi. And then go up 3. 1, 2, 3. And then come back to the middle. That's 5 points. That would be my quadrant 3. And that would be my quadrant 4. Okay, so I have my 4 quadrants. Quadrant 1, 2, 3, and 4. I have 5 points. The beginning, the middle. I'm not going to label it them. Anyway, we have 5 points. 1, 2, 3, 4, 5. Okay. This is one period of the function. We start at -1/2. I'm going to put the arrow pointing where we started, and we went all the way to 3/2. Okay. It doesn't mean that I end at 2 pi. The length from -1/2 to 3/2 is 2 pi. Okay. So let me put right here. 2 pi was our period. How do I know that? Because I cover quadrant 1, quadrant 2, quadrant 3, and quadrant 4. I know that for sure because it's represented right here. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That is one full period of my graph. Okay. What is the highest value we hit? We went as high as a 3. At what location did that happen? Well, let's see, right here at pi, that's the highest value we went. Pi, comma 3. You can even label like an order pair because that's what it is. Pi, comma 3. What is the lowest value? Well, we went as low as -3. At where? Don't ignore the 0. The 0 is also a degree, right? 0 pi. We're always keeping radian measure now. So we got a 0 pi. Use a different color to extend the pattern in both directions. I want you to go all the way from, I want you to go all the way to -½ and all the way to 3 pi. Well, let's do it then. Continue the pattern. We're going to go all the way to 3, stop right here. And it wants us to go all the way to 3 pi. So let's continue the pattern. Okay, down to 3, back to the middle, line of equilibrium, and then up to a 3. So let me go ahead. You can leave it dashed. It doesn't bother me. Ask your teacher if it bothers her or him. They're all hers. Okay, so there we go. Okay, so, and you can even put dash, 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 continue forever, because our domain is -infinity to +infinity. Okay, our domain is -infinity to +infinity. Our range is from a 3, actually from a -3 to a 3. Okay, all right, so that's pretty much it, over and over and over, the nice wavelength of a sine function. Wave curve. All right, I'll do one more with both shifts, horizontal shift and vertical shift. I will do number 3. I want red. And I want you to do number U, because you're awesome. You're going to do number 4. And then we're going to talk about number 4 in class. Okay, we'll go over number 4 in class and we'll do a couple more to practice. Okay, I'm going to do the hardest one because I'm nice. There we go. That's the amplitude. It's positive. So let me put amp. Okay, the amplitude is 3/2. Well, if you want to deal with decimals, it doesn't bother me. 3/2 is 1.5. Okay, it is positive, so that means my graph is going to start from the beginning. It's going to go up the direction that's positive, back to the middle, down, and then back to the middle. Okay. So there's our 5 points. 1, 2, 3, 4, 5. My direction is positive. My amplitude is 1.5 or 3/2. Right? Okay. Is there any shift? Is there any translation? Sure there is. We are going to positive ½ pi, and we're going to up to. Okay. So that's where we're going to be going. So let me go ahead and label. ½ pi, 3/2 is here, 5/2 is here. There we go. That's our starting point at ½ pi, comma 2. Oop, it starts right here. So that means I shifted my function to the right and up. So there we go. So this becomes my line of equilibrium. This is my midline. You can call it midline if it's an easy sentence for you, easy word for you to say. That's my midline. I don't come back to x-axis anymore. Okay, I shifted up here. Okay, so let's go. We move over to the right and we go 1.5, which puts me right here. Let me label it so I don't forget. 3.5. That's 2 plus 1.5 makes 3.5. We come back to the middle, the midline. Then we go move over and we go down 1.5, which is right here. And then we come back to the middle. We have 5 points. Look, quadrant 1, quadrant 2, dos, quadrant 3, and quadrant 4. So I have one period of the function, and one period of the function is always 2 pi. Okay. So what is the amplitude? 3.5, or you can say 1.5. It depends on how your teacher, if she's wants one way or another. What's the period of the function? Well, I showed all my 4 quadrants, and that means it's 2 pi. Let me put it right here, 2 pi. Ms. Myers, how do you know? Because it doesn't make sense. It's from half to 5/2. Well, let's go ahead and do a subtraction. From 5/2 minus 1/2 pi, pretend there's a 1 in here, 5 minus 1 is 4, and 4 divided by 2 is 2. See, so there's our 2 pi. A period of a graph, sine graph, is always 2 pi. We shifted from 0 to a half, so instead of ending at 2 pi, we ended at 5 pi over 2. Okay, so we started here, and we ended here, and that still equals 2 pi. Okay, so I would love for you to try number 4. Okay, and then we're going to go over in class all the details. I'll ask you for the amplitude, I'll ask you for the period, I'll ask you for the highest value, I'll ask you for the lowest value, at what location you hit the highest value, and so forth. Okay, so that concludes our sine function. Okay, that's it. Great work. Goodbye.